Good morning, everybody. I am Dr. Dhondiba Ishwanath, Assistant Professor of Chemistry, Government First Grade College, KR Bangalore. Today I am going to discuss about first session of mathematical concepts for chemistry, which is belongs to first semester BSc, affiliated to Bangalore North University. In this class, I have to discuss about the first concept, logarithmic relations. Now, what are the objectives of this session under the heading learning objectives? We can say that is we can define meaning of logarithm. Second one is type of logarithmic relations. Third one is rules for finding the logarithm. Fourth one is applications of logarithm in chemistry. And fifth one is solving problems on logarithm. This we have to discuss in this session. Now, what are the outcomes or session outcomes? After completion of this class, what you have gained the knowledge, that is nothing but you have to able to define logarithm. Then you have to able to what are the types of logarithm, then how to find the logarithm, you know certain rules for finding the logarithm, then what are the applications of logarithms in chemistry, then how to solve that is a particular problem on logarithm, that you have to know after this completion of this session. Now, uh, before going to that this session, what you have already know, you have already learned, already known about mathematical formulas. Simple formulas are you have already known. That is how to addition, how to make addition, how to make it is subtraction, how to make multiplication, how to divide by one quantity by other quantity. These are already simple problems you have already known. Again, that is you are already known about how to refer the logarithmic table, logarithm and anti-logarithm, how to find, no, that should be a you have already known. Then again, simple calculations, this is the addition, subtraction, multiplication, taking the logarithm, you have already simple calculations you have known. Now coming to that is a what is the actual, that is a what is the actual concept of this chemistry. Now here mathematical concept for chemistry. Now it is a heading. This is the 4 hours chapter, actually 4 session chapter, and in this session I have to explain only one concept here. The now here what you how do you define that is a mathematical concept for chemistry means certain laws or principles or formulas of mathematics are used to study the certain aspects of chemistry called mathematical concept for chemistry. Some important mathematical concepts for your syllabus listed below. First one is logarithmic relations, second one is curve sketching, third one is differentiation, fourth one is integration, and fifth one is probability. These are the five mathematical concept kept for your syllabus. And today we have to discuss about first concept, that is the logarithmic relations. Now what is mean by logarithmic relations? Now, logarithmic relation was given or discovered by John Napier, and he was defined as if a to the power of m. Here, a is nothing but base of the base, and m is called as a index or exponent. Exponent or index. Therefore, we are writing that is a into a is equal to a square. A into a means it is a cube. Suppose a into 10 times means it should be a to the power of 10. Suppose a into 1000 times it is a multiplication by a itself, then it is called as a to the power of 1000. And finding the value is very, very difficult. Suppose we take that is a 2 to the power of 2 means we will get that is value 4. It is easy. Suppose we are taking that is a 2 to the power of 64 means it is a very, very difficult. You can find, but it is very difficult to find immediate the value, and that situation the it is indices logarithm is very much applicable. Therefore, if a to the power of m is nothing but it is a is the base and m is nothing but index, that is equal to n, then where a and n are two positive real numbers such that a is not equal to 1, then m is called logarithm of n to the base a, and that is can be written as logarithm of n to the base a equal to m. This is called as a definition of logarithm. Therefore, suppose we are taken that is a this like value, then this can be also can be written as log of n to the base a equal to m. Now coming to that is what are the types of the logarithms or classification of logarithms. Based on the types of the logarithms, based on the types of the bases, the logarithms are classified into two types. Namely, first one is natural logarithm, another one is common logarithm. Now we have to study one by one. First one is natural logarithms. A logarithm whose base is e called that is a natural logarithm, where value of e is equal to 2.17828, and it is denoted as ln x or log x to the base e. We can also that is denoted. Now another one is, but natural logarithm is it is not useful for calculation purpose. Okay, we cannot be calculate by using natural logarithm. If natural logarithm is will be there, that should be converted into 10, that is a base 10, or it is a common logarithm, it is a base 10. Therefore, the another that is a type of the logarithm is nothing but common logarithm. A logarithm whose base is 10 called that is a common logarithm. It is denoted as log x, log x, or it is a log x to the base 10. Log x means it assume as a it here base 10 will be there. Here log that is a ln x means it indicate as a base e is always there. Therefore, these are the two types of the logarithms are there. Now, what are the relationship between, what is the main relationship between natural logarithm and common logarithm? Here, an equation or relationship between natural logarithm and common logarithm is given by ln x is equal to 2.303 into log x to the base 10. Therefore, this is the common logarithm. The natural logarithm is equal to the multiplication of 2.303 factor to the common logarithm is, that is a relation between that is a natural logarithm and common logarithm. Therefore, we say that is a ln x is equal to 2.303 into log x to the base 10, or it is also can be written as log x to the base e equal to 2.303 log x base 10. Therefore, it is conversion, then we can calculate. Now next, laws of logarithms. Now how to find the logarithm? Therefore, certain rules are laws possessed by the logarithm. First, that is rule goes to that is the logarithm to the base itself. Logarithm to the base itself is 1. That is the logarithm to the base itself is 1. Therefore, we say that is in general log x to the base x means always 1. Log 100 to the base 100 means it is a 1. Therefore, we say that is we know already log, therefore only two bases are there. One is log e, that is a base is e, another one is base 10, but not 100 whatever may be. But we are generally saying that is a log x to the base x is equal to 1, or log 10 to the base 10 equal to 1, or ln e to the base e is equal to 1. Now second that is the law is nothing but the logarithm of 1 to any base is always 0. Logarithm of 1 to any base is 0. Therefore, you take that is the logarithm of 1 to any base, means here two bases are there usually. One is base 10, another one is base e. Therefore should be a log 1 to the base 10 is equal to always 1. Ln there is a log 1 to the base e equal to 0. Therefore ln 1 to the base e is equal to 0. Therefore you say that is a logarithm of 1 to any base is always 0. Third is nothing but that is a multiplication rule, that is a log m into n. Therefore it can be written as log m plus log n. The multiplication of two numbers of logarithm, that should be take as a addition of log of addition of that number with log. Therefore log m plus log n. Fourth rule is nothing but division rule. Log m by n, that should be written as log m minus log n. And fifth one is, you can say that is a log of m to the power of k. K is nothing but any constant value. M also constant, another constant. We say that is a, we can written as k log m. K log m. And last, that is sixth rule is nothing but base changing rule. Suppose log m to the base a is there, that base a is should be a changes in some other that is base, then that can be written as log m to the base x divided by log a to the base x, and this is the base changing rule. Now come to that is a how to calculate, that is by using that is a logarithm. Then here logarithm consists of that is a two terms usually. Logarithm consists of that is a two terms. One is characteristics of logarithm, another one is mantis of logarithm. For example, I take one example that can be explained what is mean by characteristics of logarithm, and another one is mantis of logarithm, that can be explained in the form of following example. First one is first example is nothing but to find the value of log 2. Here log 2 is there, no? First our duty to find the position of decimal point in log 2. Therefore log the decimal point will be a in front of or right side of that is a 2 number, no? Therefore the decimal point will be a comes here, okay? Log 2 the decimal point here, that decimal point will be there. After the pressing the calculator, no, we will get there is a 2 2 3 4. Therefore after pressing 2 means 2 point will be a display. Suppose we are writing that is a 10 means 10 point display in the calculator, no? When we are fixing that is a decimal point, then you will get that is a, it is a fixed that position, and then it is remains as it is. Therefore you say that is a after 2, no, the decimal point will be there. You have to count that is a left side of the decimal point as a digits. Here suppose we take that is a decimal point here, then left side of the decimal point is only one digit, that is a 2 number is there, but that is a digit is 1. Therefore you have to subtract that digit from 1, you will get that is a 1 minus 1, that is a 0. Therefore 0 is the characteristics of log 2. Then after taking that is a characteristics, therefore you have to write, you first you take that is a characteristics, and here 0 is the characteristics, then you have to put decimal point compulsory. Then you have to, it is only one number, no? So, the logarithm usually takes in the table, no, 4 digits will be a essential, or at least 3 digits will be a essential. Therefore logarithm is starts with 10 value, no? 10 11 12 13 up to 99. These up to 2 decimal numbers, two digit numbers begins with 2 digit numbers, means 10 11 12 13 whatever may be. Therefore you take that is 2, no, that is 20 under 0 you can see. Therefore after that is a 2 see, that is a 20 under 0, that is the value will getting, no, that is called as a mantissa. Therefore after seeing 20 under 0 in the logarithm table, we will get that is a 3010, and this is called as a mantis of log 2. Therefore, we say that is a log 2 is equal to 0.3010. Okay. Now, next I take another example for finding the logarithm value here. Find the value of log 0.3. How it is takes now solution. Here decimal point is here. Now left side means all this 0 is the decimal. It is not a digit here. It is, you can write 0.3 or 0.3 is nothing but, therefore it is a nil, that is a 0. Therefore 0 minus 1, that is the characteristics, means it is can be written as bar 1. That should be a return, that is a negative, that is a minus will be put on the head of that number, that is called as a bar value. Okay. Now this is the bar 1 is the characteristics of log 0.3. Then you have to find the mantissa. After that is putting the decimal point, that is characteristics. No, here I have kept that is characteristics 1, that is bar 1. Then neglect this is the decimal point. Then you take that is in the logarithm, no, 0.3 is not begins with 0n is not a logarithm, but it is starts from 10. No, therefore you take that is a 0 here. You have to increase the 0 value here, therefore 30. Therefore 30 under 0 you have to find that is a logarithm. 30 under 0 will get that is a 4771. This value will be get, and this is called as a mantis of log 0.3. Okay. Therefore here this should be a comes, that is after seeing the logarithm table 30 under 0. Therefore log of 0.3 equal to bar 1.4771. But bar value is not a, but bar value of any number is meaningless. We are not using that is a bar value in the commercial purpose. That number should be either positive or negative. It is for calculation purpose, or in the in the commercial purpose we are using negative and positive value, but not using as a bar value. That should be a convert into negative value, so that bar 1.4771, that can be written as minus 1 plus 0.4771 we can write. Then subtract minus from minus 1 this number, we will get that is a minus of 0.5229. This is the value, no, we will get that is a logarithm value. Hence the log of 0.3 equal to minus 0.5229. This is the logarithm value of this log 0.3. Then another I will quote, that is the third example. Find the value of log of 0.00523. Here, now find the first characteristics. Always you have to find out the characteristics and then put the decimal point. Then you have to find the mantissa. Okay, clear? Now here, the left side of the decimal point, that is a 0 is there. Then suppose after left side, that is 0 is there. No, if continuous zeros are there, suppose continuous 0 towards the right side also there, that will be converted into bar value. Therefore here 0 is nothing but 0 minus 1 means bar 1. Then it should be a bar 2. Then this should be a bar 3. Therefore bar 3 is the characteristic of this logarithm. And mantissa, then you have to, after putting that is a characteristics, means bar 3 I have kept here. Then neglect that is a decimal point. Then we will have a number only 0 0, no, 5 2 3 means it is simply 523 is the number. Therefore you have to see that is a 53 under 0 in logarithm table. That will be get, that is how much, 7267. 7267 will be value, and that should be a 7267. Therefore bar 3.7267 is the value. But again bar value of any number is meaningless. It should be converted into negative values. So the bar 3.7267, that can be written as minus 3 plus 0.7267. Therefore, after subtracting, we will get that is a 2 point, that is minus 2.2733. This is the value of that logarithm. Negative value, that is minus 2.2733 is the value of log of 0.00523. And last example I quote here, find the values of log 1234. 1234, that is the value. How to it is solved? Here the how many, that is the decimal point will be here, after that is 4, no, 4 after decimal point, this will be there. Therefore 4 numbers will, 4 digits are there. Therefore we find the characteristics will be nothing but 4 minus 1, that is the 3 is the characteristics of this logarithm. Then you have to find the 12 under 3, then mean difference 4, you have to add 12 under 3, you will get that is some value. Then you have to go towards the right side horizontally, and you have to see above, that is at 4, that is mean difference will be there. Under 4 you will get that is some value, and that you have to add, you will get that is a 0 point, 0 point, will get that is 0.913, will get that is value. This is called as a mantis of this logarithm. Here how it is say, after seeing in the logarithm table, 12 under 3 is 0.899 will come. Then you have to go straight, that is horizontal manner. In mean difference 4 you have to see, that is 14 will be there, and you have to add up this, you will get that is a 3, this is the characters, and mantis I will be 0. That is the 913. And this are about, that is how to calculate. I have so far I have to explain how to find the logarithm values from the logarithm table. Now coming to that is the applications of logarithms in chemistry. It is used in the determination of pH value. We know that pH is equal to negative log of that is the base 10 of molar concentration of hydrogen atom, molar concentration of hydrogen atom. Or we can also calculate, that is a H plus molar concentration of hydrogen, molar concentration of hydroxyl ion, or we can that is a hydrogen ion here. Again molar that is, we can say, that is calculate, that is pKa value similar to pH value, pKb value, that is a we can calculate dissociation constant. These are the, we can be determined by using a logarithm. The second that is the application is nothing but it is used to solving the problems on chemical kinetics, because in we taking, that is the formula in the logarithm, that is in first order reaction and second order rate constant, no, we will get that is a log, that is a value, log function will be present. Therefore we can use for calculate, that is a chemical kinetics problem can be solved by using logarithm. And third one is, it is used for solving the problems on photochemistry. Photochemistry also, that is a, we will get, there is a Beer-Lambert's law, no, Beer-Lambert's law will be there, and on the basis of Beer-Lambert's law, that problems we can be solved by using logarithm. Now coming to that is here in chemistry, no, most likely to be asked the following type of the problems on logarithm. The some more problems I have to solve from logarithm, and usually this type of the problems will be asked in the question paper. So suppose first problem goes to, if the value will be given, and find out that, because you require, that is the logarithm table, but examiner will not be, the invigilator will not be provided, that is a logarithm table, and examiner don't know that is a, you require, that is a logarithm. For that, for sake of that problem, to solve that problem, the examiner set the question paper such that he or she will give, that is a value, log value of certain number, and find the logarithm of other number, higher number. That will be a such type of the question will be asked in the examination. First one is, if log 2 is equal to 0.3010, then find the value of log 256. How it can be solved this problem? Given that log 2 is given, therefore 0.3010, then finding the value, what you have to find? The log 256. Now knowing the value of 2, already log 2 is given this much, and find the value of log 256. Now log 256, no, here no, 256 makes such a that in the form of, that is a multiples of 2. Therefore you have find the factors of 256. 256, how it is get? It is factorized by, therefore I factorize here. 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16 into 2, 32, 32 into 2, 64, 64 into 2, then 132, 132, 132 into 2, that is a 256. This is just like this factorization will be takes place, and therefore I can write that is a 256 into 2 into 2 into 2 into, that is how much? 8 times of 2. Then that can be, this number can be written as in the form of laws of indices, that is the 2 to the power of 8. Otherwise we can be also be solved by using you know that log m into n into o into p into whatever may be, then the multiplication of the logarithm, the log of multiplication of any number, that should be add up log of that number, no. Therefore we can write, this can be written as, we can write log 2 plus log 2 plus log 2 plus log 2 8 times. Then you know that log 2 value is nothing but 0.3010. Then you have to substitute and add it, you will get that is this value. Otherwise we can simplify this, that is a this 8 numbers, no. Therefore log of 2 to the power of 8. Then again you have to follow the another property, log m to the power of k, that is nothing but k into log 2. Therefore 8 log 2 will be there. Then again 8 will be there, 8 into log 2 value, you know that is this value here, and substitute this value, you will get that is after multiplication you will get that is a 2.480. Therefore log of 256 will be get that is a 2.480. A second problem we will get that is how to solve that is second problem. Similar to this one, another problem I have to solve here. If log 3 will be given, if log 3 0.4771 and log 5 will be given, that is a 0.6990, then find the value of log 150. Now our duty to find that is a 150, no, log 150, no. You make that is 150 in the form of making the factor in the form of 3 and 5 only. Then only we can able to calculate. Therefore solution, given that log 3 is equal to 0.4771 and log 5 is equal to 0.6990, then you have to make actually this value actually 225, actually here by mistakenly here written, that is a 150, but it is a 222. I have taken here log of 225, log 225. Then log 225 is nothing but you should be multiply that. What is the log of 5 into 5? 5 into 5, that is a 25. 25 into 3, 25 into 3, or that is 25 into 3 means that is 125. 125 into 3, how much? Therefore 3 3 is a 9, 25 means it should be a 250. Therefore we can write this is the 225, no. 225 can be written as 5 into 5 into 3 into 3. Okay, therefore this can be written as 5 to the power of 2 and 3 to the power of 2. Then you have to take log of 5 to the power of 2 plus log of 2 to the power of 3 by multiplication, addition. This is the another formula. Then you have to take that is the 2 log 5 plus 2 log 3. Then you have to take that is the 2 log 5 is nothing but you know that value 0.6990 plus 2 log of 0.4771. Then you have to multiply this, you will get that is a this much value multiply, then you have to add, therefore you will get that is a log 225 is equal to 2.3522. This is the value. And similarly for calculate this value here, find the value of log 77. If log 7 is given and log 11 will be given, from that you can calculate. Again that is, this is the homework for you people. Again find the value of log 7 by 3. If log 7 is equal to 0.8451 and log 3 will be given, this formula should be a apply, that is hint I will give, that is log 7 minus log 3. Then substitute value, you have to take subtraction, you will get the value. For this the log 77 no, that you will be a 7 into 11, therefore log 7 plus log 11, therefore you are put this value, we add it, you will get that is the value. These are about that is the this is the simple problem. One more I will take, that is one more I will solve, that is problem. If pH of the given solution is this much, find the value of H plus concentration, H plus ion concentration. Then given that pH is equal to 6.34, then H plus ion concentration, we know that pH is equal to negative log to the base 10 of H plus ion, then negative log this much you have to write. Then this will be a convert, that is a minus value 6.34. Then this minus no, you have transfer this log into antilog, this value. But here the antilog will be, that is a negative value no, negative value should be a convert into antilog value, that is a bar value. The antilog of negative value, it is not possible, so we have to convert negative value into bar value. For that we have to we can written as minus 6.00 minus 0.34. Therefore after taking that is subtraction, minus 7 plus 1, we can write that is a minus 6 can be written as minus 7 plus 1, then minus 0.37, then subtract that is a 1 from 1, that is 37, means it will be a 66, and this is the minus 7 will be there, that should be a bar 7. Therefore this is simple calculation will be there. This value should be a removed from the 0, means you have to make that is a minus 6. It is a split up into two manner, minus 6 that is a minus 6.00, again that is you have to minus 0.34. Therefore you are adding minus this much no, therefore minus 6 can be written as minus 7 plus 1, means again minus 6, there is no change in value, and this should be a minus 0.34. Therefore take the subtraction from 1 this value without changing this, and this will be converted into bar value. Therefore bar 7.66 will be there. Now the H plus ion concentration is equal to antilog of bar 7.66 is nothing but you have to the anti-logarithm start from 0.01 no, therefore you can see that is the antilog of table 0.66 under 0, we will get that is a 4571. Therefore you have to put that is a 4571 as it is, and you have to add 1, or just you have to shift the decimal point from right side 1 decimal, that is 4. After 4 you have to put that is the decimal point, and the remaining numbers will be same, and that this is the bar value no, that should be a place in written in the form of index, that is a 10 to the power of minus 7. Therefore here simply that after that is taking antilog, we'll get there is a 4571. Then you have to put the decimal point. uh, for that you have to add 1, no, to that bar value. But instead of putting that is a bar value, adding the 1, you just you shift the one decimal from left side to right side. Then 4.571 into 10 raised to minus 7. This is the value. Next, what are now, so far we have studied about what are that mathematical concept for chemistry definition you have learnt, logarithmic relations you have already learnt, then how to classify the logarithm you have already discussed, then how to what are the rules for finding the logarithm you have already learnt this session, and what are the applications of logarithm in chemistry you have already learned, and how to solve the problems you also, that also you have to learn. These are the I have discussed in this session. Now so I will ask some questions based on that is so far I have discussed, no, just I have asked some questions. Please answer the correct option. Okay, now first answer question goes to that is a logarithmic relation is given by, who is logarithm relation is given by, the four options will be there. Arrhenius will be there, Newton will be there, Maxwell Boltzmann will be there, and last one is John Napier will be there. Now which one is the correct answer? You have to think and you have to answer immediately. I will just give that is a 10 seconds for you people. You answer. Now the logarithmic relation is given by that is a John Napier. The logarithm, the relation definition beginnings itself is there. No, I have explained. The John Napier is given the logarithmic relations. Okay, therefore the D is the answer of this question. Second question, to convert natural number to common logarithm by multiplying a factor, which one? Now here first option goes to 2.303, then 23.03, then 0.2303, then none of this. I will give 10 seconds for you people. You think and answer the correct. The answer for this question is A option, that is a 2.303 should be multiplied to the common logarithm, that is becomes equal to natural logarithm. Okay, therefore answer A, that is option A is the answer. Third question, the value of logarithm to the base itself. What is the value of logarithm to the base itself? I will give that is here four option will be given. A option that is a 0, B option 1, C option 2, and D option none of these. I will give that is a 10 seconds for you people. You can answer choose the correct option. Now option answer of correct answer of this question is nothing but B option, that is a 1. The property will be there, that is the logarithm to the base itself is always 1. That is the first property of logarithm. The logarithm to the base itself is always 1. Therefore B option is the correct answer. Then fourth question, the value of logarithm of 1 to any base is, what is the value of logarithm of 1 to any base? The options will be four options given. A is nothing but 0, B is nothing but 1, C is nothing but 2, and D is nothing but none of these. I will give that is 10 seconds for you people. You choose the correct answer. Answer for this question is A option, that is 0. This is the second property of logarithm is there. Logarithm of 1 to any base is always 0. Therefore, it is the option A is the correct answer. Then fifth question, characters of logarithm 1354.004. What is the characteristics of this logarithm? The option A is nothing but 0, B is nothing but 4, C is nothing but 3, and D is nothing but 7. What are the options here? I will give that is the what is the correct option in this question. I will give that is 10 seconds for you people. You can choose the correct option. The correct answer of this question is C option. It is the characteristics will be 3 because here decimal point will be there. Left side of the decimal point, how many digits are there? That is 4 digits are there. 4 digit minus 1 digit, that should be 3, and 3 will be the characteristics of this logarithm of 1354.004. Therefore, option that is C will be the correct answer of that question number 5, that is characteristics of logarithm of 1354.004. And this complete there is a session 1 of mathematical concept. In next class I have to take that is a second session of same topic. I have for that, for preparation of this session, I have refer some books. These books I have referred for preparation of PPT or notes or multiple choice questions, everything by using these books. Thank you.